Part two. Hope you enjoyed part one. Nothing like a good long video of geometric proofs. So, part two, we're going to pick up where we left off. We're now going to do 6 through 10, so 5 more problems. Start off with given. That's what you always do with the proof. Start off with given. And we are given angle 1 is congruent to angle 3. Now, looking at this diagram, what is special about those boxes that I just highlighted red? They mean that these are right angles. They mean that they are right angles. Now, we're going to have to skip some steps, which I'd usually actually have students do because we don't have a name for this whole angle. But usually I'd say that this whole angle equals 90 degrees, and then this plus this equals the whole angle, and then substitute, blah, blah, blah. But we don't know what the whole angle is. So we're just going to go straight into the measure of angle 1 plus the measure of angle 2 equals 90 degrees. All right, so we're just going to go straight into the measure of angle 1 plus the measure of angle 2 equals 90 degrees. I think I might run out of room on this one. I'm going to start off with 1, then I'm going to run out of room. And we're also going to say that measure of angle 3 plus the measure of angle 4 equals 90 degrees also. It's going to be the same reason, and we're actually going to do 2 reasons. We're going to combine 2. This is really just going to be one whole thing, but we're going to have 2 reasons for this. The first reason is the definition of a right angle. The definition of a right angle is that a right angle is 90 degrees. So we're going to do the definition of a right angle. The other one we're going to use is the angle addition postulate, that 2 little angles or 2 smaller angles that make up a bigger angle, you can add them together to get the bigger angle. So angle addition postulate. Okay, so these are actually going to be a 2-in-1 special, all right? If I could, I would put those in one cell. Now, again, the issue is we don't have a name for this big angle. Usually I would come in and I would say like this is angle ABC, and then have a few more steps in here to be a lot more specific, or just a little bit more specific, but this is fine, right? They equal 90 degrees because the definition of a right angle means that it's 90 degrees. And we're allowed to add this angle and this angle to be the whole angle because of the angle addition postulate, okay? And it's the same concept over here. You're allowed to do the same thing over there. So I like where we're at, all right? Now what we're gonna do is, because this is all equal to 90 degrees, I can substitute it in for 90. All right, I can substitute in for 90 because it is equal to 90. So we're going to do substitution. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Substitution. Okay. Now what we're actually going to have to do here is we're going to have to take this original thing and change that congruent symbol. If you watch part 1, we need to get rid of that congruent symbol and change it to an equal sign. So, tired. Oh. Ain't no such thing as tired like teacher tired. All right. That was a lame teacher joke. Anyways, let's change this to the measure of angle 1 equals the measure of angle 3. And that is the definition of congruence, which we use multiple times in part 1. Definition of congruence. All right, and what that means is come in here with different colors. The whole point in doing that is we notice that we have those, one on this side of the equal sign, one on this side of the equal sign. They are equal. So I can subtract both of them off without changing the equivalence of this equation, right? That can go, right? It's no different than saying like 2 plus the measure of angle 2 equals 2 plus the measure of angle 4, and then subtracting 2 from both sides and canceling them out, all right? Instead of subtracting 2, though, we're subtracting off these angles to get just what we want. Hold the phone, though. I want measure of angle 1 is complementary to angle 4. I might be doing some wrong stuff here. Now, I think it's going to work out. It's going to work out. I'm just going to have to, I might have done this a long way. I might have done this a long way. Still going to work out. Let's subtract it off. So we're going to get the measure of angle 2 equals the measure of angle 4. So we are subtracting off subtraction property of equality. All right, we're actually gonna have to go one more step. And what that step is, well, it's, this is no bueno. This is no bueno. Crap. You know what? That's why I have a stack of white paper under this. It's gonna work out. I'm gonna make it work. Son of a gun. So let's just roll with it. Yeah. So to my students, you're gonna have to add in some cells. You're gonna have to add in some rows below to finish this off. I feel like I really did this a long way, but it's gonna work out. So measure of angle 2 is equal to measure of angle 4. And I'm gonna grab another highlighter, grab another color, because what I want to highlight here is the whole point is I'm trying to get this, right? I'm trying to get that, really in essence, what I'm trying to get is that the measure of angle 1 plus the measure of angle 4 equals 90 degrees, because that's what complementary means. All right, if I can get this, then I can get this. All right, so I really need to find this equation. But what I just have found, might have been the long way, but what I found is that the measure of angle 2 is equal to the measure of angle 4. And that's good news, okay? That's good news because I can substitute. I already see where I went, made it long. I already see where I went, made it long. I might do this one twice. I might do this one twice, just to show you that there's a long way and a short way, and there's more than one right way to prove this. Gosh darn it. Anyways, the point here is this is equal to measure of angle 2. Well, can't I substitute this in for that because I just proved that they're equal? I can. So I can come here and I can say that the measure of angle 1 plus the measure of angle 4 equals 90 degrees. And the reason for that would be substitution. All right. Okay, I got that they add to 90 degrees. That means they're complementary. So now I can say angle 1 and angle 4 are, unplug that, are complementary. So are complementary. And the reason for that would be what? The reason for that would be definition of complementary. All right, definition of complementary. I am going to show a way quicker way. I know I got extra copies over here. What is this? This is problem 6. That's ridiculous. So yeah, let me real quick put this off to the side. Let's fill in. I know exactly where I went wrong. So let's do the measure of angle 1 is not crap. Angle 1 is congruent to angle 3 given. All right. I am immediately going to just change this to be the measure of angle 1 equals the measure of angle 3. I'm just going to change that right off the bat. And that'd be the definition of congruence. Now, this is the same problem that we just went through. I'm going to do it in a more short version. So I immediately am just going to change this to this because I know I need to, because I know, right, what I know is the same as we did for the other one. I need measure of angle 1 plus the measure of angle 4 equals 90 degrees. I need this. Okay. So what am I going to do? I am going to say this piece over here. I'm going to say this piece over here. I'm going to say that the measure of angle 3 plus the measure of angle 4 equals 90 degrees. I don't actually need to mention this at all. I don't need to mention that. You can, but you don't have to. So I am going to mention this bit right here. And this would be for both the same reasons that we did last time. So this would be the definition of a right angle and the angle addition postulate. All right, that was all one reason. Well, I can just go straight from here. Instead of doing everything I did last time, I can just take the measure of angle 1 and substitute it in right there. And I immediately get right away that the measure of angle 1 plus the measure of angle 4 equals 90 degrees. And that is by substitution. And then that means they're complementary because they add to 90 degrees. This is what I spent a whole bunch of steps proving the last time. So angle 1 and angle 4 are complementary. And that would be the definition of complementary. All right, instead of doing, how many steps did I do? I mean, it wasn't many more. It was just 3 more steps. This one was just 3 more steps. But there's shorter ways to do it. So don't always feel like if it's going for a while, I mean, there's one way to go about proving it. There's obviously wrong ways, but there's more than one way, right? So go with your gut. And then always ask your teacher for help or check for understanding with your teacher, and they'll guide you towards the correct way if you had a mishap. I really enjoy it when my students find another way to do it other than the way that I would have done it. Okay, so let's keep going. Let's go here. So what do we know? We are given segment GE bisects angle FGD. All right, that is given. What does bisect mean? Bisect means to cut in half. So that means that this segment or ray, I should have called it a ray. I should have called this ray GE. Bisects this whole angle. And bisect means to cut in half, so we know that these are congruent angles. We know that because that is the definition of bisects, or definition of angle bisector. So definition of angle bisector, and that would be that angle 3 is congruent to angle 2. All right, because 50% is congruent to 50%. A half is congruent to the other half. Okay, well, what else do we know? We know that this angle hopefully we know anyways that this angle and that angle are vertical angles, and the definition of vertical angles is they're congruent. So angle 1 is congruent to angle 3. Definition of vertical angles. Okay, so this is what I'm trying to prove. Angle 1 is congruent to angle 2. So I am going to take, because that and that, I am going to take angle 1 and substitute it in for angle 3 because it's congruent to angle 3. So I can substitute it in. So angle 1 is congruent to angle 2, substitution. And that's what I was trying to prove. I just proved it. So I was trying to prove 4 steps, 4 quick steps. All right. That is problem 7 done. All right. Ooh, problem 8. Whenever I see segments with littler segments inside, I immediately know I'm going to have to add segments. So I'm going to have to use the segment addition postulate at some point. Okay. So given AC equals BD, right? That means that this piece is congruent to this piece. And that shows me that there's something overlapping that we can subtract off both sides, BC. But what we're first going to want to do is, well, what adds to BAC, right? What adds to BAC? AB plus BC equals AC. Okay, well, what adds to BD? Well, that would be BC, comma, let's put a comma there, plus CD equals BD. So this plus this is AC, and this plus this is BD. All right, and that, oh, well, this is given. And this would be the segment addition postulate. All right. Well, don't I know that these are equal? So can't I take this here and substitute it right there? And can't I take this here and substitute it there? Yes, I can. I can do that. So I'm going to say AB plus BC equals BC plus CD, and that would be substitution. Awesome. Okay, well, isn't that the same thing on both sides? So let's just subtract it like we would subtract off a 2 from both sides. Let's subtract that off from both sides and get AB equals CD, subtraction, property. Perfect. Subtraction property, subtracted off BC from both sides. I actually just proved what I was trying to prove. Let's get rid of this. Don't need it. Awesome. 4 steps. Perfect. Number 9. So we are given measure of angle 1 equals the measure of angle 2, and the measure of angle 3 equals the measure of angle 4, given. Okay, so I'm going to use the angle addition postulate, right? So I'm going to have to use the angle addition postulate. I'm not solved this one, so let's find out. So I'm going to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. I'm going to also say that the measure of angle 2 plus, wait, this is a 3. That's supposed to be a 3. Let's make that a 3. And the measure of angle 4 equals the measure of angle DEF. All right, these are both going to be the same. These are angle addition postulates, like little plus little equals big, little plus little equals big angles, right? So this is the angle addition postulate. All right. What can we do from here? What can we do from here? Well, probably some sort of substitution, I would imagine. Measure of angle 1 is congruent to measure of angle 2. Measure, oh, okay, I know what I'm going to do here. I know, yes. I know what I'm going to do. I can see that these can be substituted for each other, and these can be substituted for each other. So I'm actually going to, for this one, I am going to substitute in the measure of angle 1 plus, because I just substituted in 1 for 2, and here I'm going to substitute in 3 for 4, the measure of angle 3 equals, and really, actually, let's make this blue, equals the measure of angle DEF. So I just use substitution. All right, so I substituted in 3 for measure of angle 4. I substituted this out for this because it's equal, and I substituted in measure angle 1 for measure of angle 2 because it's equal. Right? So what I have now is this and this are the same thing, but I have this set equal to the measure of angle ABC. So what I can do is, and actually let me use a different color. Where's blue? Actually, let's use green. Is I have this and this, but it's set equal to a different piece. So I can take this measure of angle ABC and substitute it in. All right. So I can substitute that in now, and I will get the measure of angle ABC equals the measure of angle DEF using substitution. No, that's what I was trying to prove. I was trying to prove that. I did it right there. All right. Don't know if that's the quickest way or the way that makes the most sense. Works out, right? You're given this, and basically they're giving you, in this given, it's giving you substitution. You're going to be able to substitute that in for that or that in for that, right? You can, these are interchangeable now because they told you that they were. And you start off with the angle addition postulate, right? You start off with this, right? That this guy plus this guy equals the whole thing, and this guy plus this guy equals the whole thing. and then you just substitute using this step in, right? You use this step to do the substitution. And then you substitute it away. Substitution, substitution. I think that makes perfect sense. Hopefully it does to you too. If not, rewind, rewatch that, or just don't worry about this one. I think that works out. Last one. Last one. What time is it? Getting late. All right, so we're given angle 1 and angle 2 are complementary. Given. Awesome. Perfect. So angle 1 and angle 2 are complementary. Given. We're going to want to try and prove that this whole thing is a right angle. What's complementary mean? Doesn't that mean that the measure of angle 1 plus the measure of angle 2 equals 90 degrees? I think so. So that means that these are, oh no, that's the definition of complementary. I need, this is definitely, I'm glad this is the last one. Definition of complementary. Complementary. Big N, big N, big brain time. Okay, definition of complementary. Good. I see where we need to go next, and where we need to go next is we haven't said anything about AXC, but we can. We can say that AXC is equivalent to these two little angles added together. So what I'm going to say is the measure of angle 1 plus the measure of angle 2 equals the measure of angle AXC. And that is the angle addition postulate. So angle addition postulate. Right? Little angle plus little angle equals the whole angle. Well, what that means is I can substitute, because those are the same, I can substitute this in for that. So I will get 90 degrees equals the measure of angle AXC. And that is substitution. Okay, well, if an angle is 90 degrees, what kind of angle is that? Right? What kind of angle is an angle that's 90 degrees? Right angle. So now I can say angle AXC is a right angle. And the reason for that is the definition of a right angle. All right. Number 10, done. All right. I really hope that was helpful. I'm sure there will be more videos to come as far as geometric proofs go. But yeah, so thank you for watching. Hopefully you watched part 1, part 2. I really, truly hope they were helpful to you. So again, thank you.